Hi Algebra 2. This is a quite long actually exploration of where the sine and cosine graphs come from and doing all the transformations on those graphs. I strongly recommend that you have at least 3 or 4 colored pencils or highlighters handy. You're also probably are going to want to be able to play with this on Desmos in radian mode. And next time on Monday, I will be doing a live lesson of this. So I strongly, if this is a little confusing, please come to the live lesson, because there's going to also be a second part to these notes where we've put it all together, and that will then be the expectation that you can graph all the transformations of sine and cosine. So let's get into it. Let's start with the basic parent graph. So remember from when we did 9-3 and we were entering coordinates on the unit circle. We have another unit circle right here with just the radians. Remember that sine always goes with the y coordinate on the unit circle. So what we can do is we can take these coordinates that go around the unit circle and we can then sort of roll them out into our rectangular coordinate system. And we're going to do that for sine by looking at the y values here. And so notice that at 0 degrees, sine of 0 is 0. So there's our first dot. Notice then that if I went all the way around to 2 pi, which would also end here, I'll also be at 0. So we can put those dots in. What happens when you're halfway? At pi, we look at the y coordinate. Oh, look at that, I'm also at 0. This axis here that is right, well, you don't know that it's in the middle yet, but this is called the sinusoidal axis. It's one of my favorite words in math. Sinusoidal. You got to say it like you're from New Jersey, which my mom was. So it's the sinusoidal axis. So far we have 3 points. I can also, if I were to go in the opposite direction at pi, anywhere that's at pi and negative 2 pi, I will be at 0. So let's fill in a couple other points here. Notice that at pi over 2, my y value is 1. So I'm going to make it go up 2 so that it's not so tight. So at pi over 2, I have a coordinate of 1. At 3 pi over 2, my y coordinate is negative 1. So whoops, that will put me down here. And if I were to go in the reverse direction, that would be 3 pi over 2 would be equivalent to negative pi over 2 going backwards. So at negative pi over 2, I'm at negative 1. And at negative, because this also equals negative 3 pi over 2 up here at pi over 2, if you're going backwards, that put me at 1. So how does this graph look? These are called periodic functions because they basically are like the tides pulling in and pulling out, the sun rising, the sun setting. There's sort of a rhythm to them. They repeat a pattern. So one full pattern is what it takes to go once around the circle. So starting at 0 and ending at 2 pi, that represents one cycle or one period of our graph. All right, so notice that it hits 0 at the beginning, the end, and the middle. Then it hits a high of 1 and a low of 1. It can never go beyond that, your parent graph, because the unit circle is only a radius of 1. So it will always fall between 1 and negative 1. That is your parent graph. Now what we want to look at, and I want to emphasize where we got those points, was just from the y coordinates of your quadrantal angles on the unit circle. So now what would happen if I were going to do an exploration of this and you were using Desmos, which is really what this was intended for, what would multiplying by 2 in front do to the graph? What it would do is dilate the graph vertically. So multiplying by 2, all my zeros at 2 pi, at pi, at 0, at, where's pi? Oh, I'm running off my screen here at 2 pi. So those will all still be at 0 because 2 times 0, you're multiplying the y values. That might be helpful to know. You're multiplying the y value. So if your y value is 0, you're still at 0. But now my y value when it's 1 goes up to 2. So at pi over 2, I'm at 2. And at 3 pi over 2, I'm at negative 2. And the same thing if I go backwards, this will be at negative 2, and this will be at 2. And so that graph, if we carry it through, would look, so it's dilated, stretched vertically a factor of 2. How would it look if it was just 1/2? Well, all your zeros are going to remain the same because 1/2 times 0 is still 1/2, still 0. Yeah, I can multiply. But 1/2 times 1 from the parent graph now is going to shrink you, or your graph, not you, down to 1/2. So this will be at negative 1/2, this will be at a positive 1/2, and your graph is, this is a vertical shrink by 1/2. And so if you were using Desmos, you could add a slider and play with that slider to see how different aspects would affect your graph. One of the things I do want you to see, I didn't put one in here and I'm going to add it to the mix. What if I had y equals, let's say, negative 2 sine x? So the 2 is a dilation, the negative is going to be a reflection. So what happens is, again, we have a lot of, we're still at 0 at all these 0, pi, and 2 pi, but the negative is now going to take me down to here, up to here. So I've reflected my graph over the x-axis. So if you have a negative, it would look like this. Kind of pretty when you look at it all at one time. Hopefully you can play with this on Desmos just so you can get a feel for it. What this is called is amplitude. That A right there, it affects the amplitude. Think about like how loud is your graph. So the higher the graph, the more stretched out, the bigger the amplitude. All right, now let's look at the next potential transformation. This one is inside, and this one is sometimes a little bit hard to calculate. This one tells you how many cycles you can complete. Actually, I have it down here. How many cycles can you complete in 2 pi? Because remember, your parent graph completes 1 cycle in 2 pi. So what that means is 2 pi is the period of your parent graph. It takes 2 pi to complete 1 cycle. 2 pi is that distance the graph will travel horizontally before it starts to repeat the cycle, the pattern. Think of the cycle as the pattern. So you want to just do one pattern in that distance. What 2 says, so that b value, if it's right inside in front of the x value, this means I can complete 2 cycles in 2 pi. So what does that mean? That means that my new period, which we label p, is always going to be 2 pi divided by whatever that value gets, it's a b, 2 pi divided by b. That's going to be the new, how long it takes to complete 1 cycle. So if I'm doing 2 pi divided by 2, what that means now is I can complete a full cycle, an up and a down within a distance of pi. So if I'm going to graph that, at 0, I'm still starting at 0. That's always sort of a starting point for your sine. Then I know I'm going to be done with a cycle at pi now, not at 2 pi. So that means halfway, I'm still at 0. So notice I still have those 3 zeros, beginning, end, and in the middle. And now, so if that was at pi over 2, this will be at pi over 4. That is now where I'm at a height of 1, because notice my amplitude here is 1. And at 3 pi over 4, which is what that value is, I'm now down here at -1. So it only took, what that 2 did is it shrunk my graph horizontally. So I could complete a lot more cycles within 2 pi. That is one cycle. So the new period here is going to be a period of pi, because it only took me a distance of pi to complete my cycle. I could keep going. So I have my beginning, middle, end, and if I wanted to draw the 2 cycles, it would just keep going. It just keeps continuing. And again, I could do it backwards as well. Whoops, I hit another color. It would come back to -1, up to 1, and you could then just keep going. You don't have to draw, cycles to fill it all out, so long as you understand where you're at. Now, if the number under here is 1/2, so that's 2 pi divided by 1/2. That means I can do half of a cycle. That would be just like going from 0 up to 1 back to 0. That would be half of a cycle in a matter of, if I invert and multiply, this becomes 4 pi. So it takes 4 pi to do a full cycle, which means I can do half a cycle in 2 pi. Remember, that's what B means. How many cycles can you complete in the normal 2 pi? I can do half of a cycle. How does that look? Well, that means I'm still going to start at 0. My middle, the normal middle, is going to be at 2 pi, because I would go out to 4 pi to finish off the cycle. So halfway is going to be my high point. And then just so we can show a complete cycle, I'm going to go back so we have a full distance of 4 pi, from -2 pi to 2 pi. Halfway down here is going to be at -1. So this is how this looks. It stretches your graph out. So it kind of works the opposite. I don't know if you remember with our horizontal translation, they always work the opposite of what you expect. So you see a big number like 2, it actually means your graph shrunk by 1/2. If you see a number like 1/2, you actually stretched your graph so that you takes twice as long to finish one cycle. So instead of 2 pi, you now takes 4 pi, because you can only finish half of it in the same distance. All right, so this is called a, it's not your horizontal shift, it's your, let me see, I'm getting, I always never know what to call this. What do I want to call it? My phase shift? I guess I'll call it, let me come back to what I want to call that. It's just, yeah, it's B is, right now I'm going to call it number of cycles in 2 pi. So that number tells you can either do 2 cycles in 2 pi, half of a cycle in 2 pi, and you figure it out by going the period, this is your new period, equals 2 pi divided by B. That tells you how the distance it'll take to complete your one cycle. All right. Okay, so putting it all together again, we have here A sine BX. What that means, so here was our sine, at all the pi's, we went up to 1, down to a -1, So 1 here, and again, this is just doing your parent graph, and to bring it all together. So when we look at this, you can see the domain is going to be all real numbers because it keeps going. However, your range is going to be strictly between -1 and 1, including those points. Your amplitude, the amplitude, which is that A value, that is the distance your graph goes from the sinusoidal axis. So remember, this is called your sinusoidal axis. It is the axis that runs through the middle of your graph. So that distance is your amplitude. So for the parent graph, the amplitude is 1. And your period is how long it takes to complete one cycle before the pattern repeats, and it will be 2 pi. Now we're going to go through the same process with those two transformations on a cosine graph. So let's look at your basic parent cosine graph. And again, there's going to be a total of 4 transformations. So far all we looked at is amplitude and your period. So y equals cosine x. Remember, cosine goes with the x coordinates on the unit circle because that's your adjacent. So when we look at the x coordinate, unlike sine, which started on the sinusoidal axis, cosine starts high. So at 0, we have the coordinate at 0 degrees, because remember this is, or 0 radians. At 0 radians, you're at a height of 1. And if we went all the way around the circle, that means you'd also end at 1. Now let's look at what happens at pi. You're at -1. So in the middle. So cosine starts high, ends high, halfway it's at the low. At pi over 2, the coordinate is 0. And at 3 pi over 2, you're also at 0. And this then translates backwards. So at -2 pi, you'd also be at high. At -pi, you'd be here. And at the pi over 2's, you would be at 0. So a cosine graph, it kind of looks like a handlebar, one cycle of it. One of those bicycles with the big handlebars. All right, so again, notice that one cycle only takes 2 pi to complete. So this would be one cycle, one period. And then we're going to look at, that's your parent graph. And we want to look at then how those transformations. And again, at this point now, it's going to be the same effect, but we're doing it to a cosine graph. So 2 again, this is going to be your vertical dilation, same as before. A now, this number represents your amplitude. So if I'm doing 2, instead of going up and down to 1 and -1, my high will be at 2. So here I'm going to be at 2, and in the middle at pi, I'll be at -2. So just to do one cycle, oh, and I hit 0 because 0 times 2 again is still 0. So when you do your graph, and I always like it, it doesn't end there. So always kind of keep the curve at those high points. Those are actually turnarounds. So I always like to kind of show the full graph, like it's going to keep going. Don't just stop there. That would be one cycle. I could carry it backwards. It would be down here, up at 2, and there you go. There's 2 cycles of a graph with an amplitude of 2. If I did 1/2, let's do kind of orangish. 1/2 would be here, so my high will be at 1/2. Still going to be 0, and 1/2. This will be a -1/2. And so my graph is basically the same graph, it's just dilated. You know what happened? Oh, sorry, I didn't see it all the way. Oh, I'm sorry about that. Let me kind of go back and fix this. Get my green. 2 pi's off the chart here. So I missed my marks. Hey, why is my eraser not working? Why is my eraser not working? What's wrong with you? I'm not sure what's happening. So those were fine. 2 pi's up here. Here was my 0. There we go. Oh. So then we went to 1/2. This is still 0. It's hard because my little controls are in the way. Here we go. All right, and I could go backwards. So 0 again is still 0. This would be at 1/2, 1/2, and there's your graph. So cosine again starts high, ends high. You still have, notice there's always 5 points, and I'm always going to ask you to graph 5 points. So where you begin, where you end, the middle, and then you have sort of your quarter points in the between the beginning, the middle, and the end. Now we also, and what if you had a negative? How would that look? Well, if I had a y equals -2 cosine x, that again is a reflection. So all your zeros, but I would start now, instead of starting high, I start low and I end low. So this will also be low. That means that at the halfway point, I'm going to be up here at a +2, and your graph, your zeros will all be the same because multiplying by 0 is still the same. And my graph would come around like this, just hitting all those points. It really is, if you can put the 5 points down, it's really then just connecting the dots. That's kind of my goal with these. All right, let's look at your horizontal translation here. So again, this is your b value. So this is going to mean I can again do, so b equals the number of cycles you can complete in 2 pi. So if I have a 2 there, 2 pi divided by 2, so again that means I can do 2 cycles in 2 pi, which means it only takes me a distance of pi to complete a full cycle. So again with cosine, you start high and you end high. So now it only takes a distance of pi to complete 1 cycle. That means at halfway, I'm here at my low, -1, and the quarter points are at 0, and this would represent 1 cycle. If I wanted to show the full 2 cycles, it would not be that point. It would be, because we're going to end high, halfway would be the low. There we go. And hit those zeros in the middle. So that shows 2 cycles in 2 pi. That's what that 2 means. If I do the 1/2, that means I only takes half. I can complete half of a cycle. Half of a cycle would be just from the top to the bottom. That's half a cycle. So if it takes 2 pi to do half a cycle, it's going to take me 4 pi to complete the whole thing. So this is going to look like I start still high. I'm going to hit my half a cycle at 2 pi, which means I'm going to hit my low at 2 pi, which means I hit 0 in between. If I go backwards, that means at pi, so I'm going to do the full, from -2 pi to 2 pi is a distance of 4 pi, so I can show a whole cycle. But this is going to be a cycle that actually started down so that we can show 1 full, we went up and we went down. That would be your cosine graph. If I had more room to move forward, the 4 pi would then also end high. Okay, so putting it all together, we have a cosine b, where again, a represents your amplitude. Cosine starts high, at 2 pi it ends high. At pi is the halfway point, so it hits a low. At the quarter points, pi over 2, 3 pi over 2, you hit 0. So that represents 1 cycle, 1 period of my graph. And we could continue it going backwards, so this would be at 0, this would be a low, this would be a 0, this would be another high. So just to fill out the whole graph, usually I'm only going to make you do one cycle. So we know the domain, looking at it again, is all real. Also the range, just like before, and this is because your unit circle only has a radius of 1. So this will always between -1 and 1. It bounces back and forth. Your amplitude, again, that represents the distance from your sinusoidal axis to the high or a low, and that distance is 1. And the period is the distance it takes you to complete one pattern, one cycle, and that is 2 pi. All right, so now we are going to move on and look at some more transformations. Okay, so now we have 2 more transformations to look at. In the last one, we looked at a vertical dilation and changing the period or the distance it takes to complete a cycle. Now we're going to look at a vertical translation. So we're going to move the graph up and down. So I have to kind of change my scale so I have a little bit more room. It's going to be a little tighter. But let's review, how do you do the basic parent graph for sine? And again, if you keep a unit circle handy, remember it's always the y value. So we started at 0, we end at 0, you hit 0 in the middle. At pi over 2, you're high. At 3 pi over 2, you're low. And so this would represent one cycle. And we could continue it going backwards. It would look like this. So that would be your parent graph. What happens if we take a graph and add 2 to everything? So you're adding 2 to the y values. What it's going to do is if this is at 0, it's now at 2. 1 is now at 3, so 0 is at 2. -1 will be at 1. This will be at 2. So we're basically moving everyone up 2 units. And so this will be at 1, this will be at 2. Your new sinusoidal axis is now going through the middle. So that's what this really does, is that +2 takes the whole x-axis and moves it up to 2. So your new sinusoidal axis is at 2, and we can then just connect the dots. So there is your wave. If I had a -3, what I would do, that drops my sinusoidal. I still have an amplitude of 1, so my new sinusoidal is going to be here at -3, and you would do the same graph. We're going to start at 0, we end at 0, halfway point at 0, but it's 0 on the new sinusoidal axis. Amplitude is 1, so I went up 1, down 1. So this would represent one cycle. So it doesn't change your graph at all. All it does is lift it up. So that's why it is a translation. It just picks the graph up and moves it up or down depending on what that value is. Oh, delivery trucks. Gotta love those backup beep, beep, beeps. So C is going to represent a vertical translation. It doesn't change the shape of your graph, it just picks it up and moves it up or down. So let's review what the cosine, your basic cosine graph. Remember, I am gonna, let me put my new scale on here, 1, 2, 3, 4, -1. Okay, so your basic cosine graph, remember, started high, and it, I was losing my 2 pi over here, ends high. In the middle, it's at the low, and at halfway between those, it hits your sinusoidal. So it's like a handlebar again. So that was your basic cosine, which we can take it backwards as well. And so we show a full 2 cycles here of the pattern. And now this first one, again, now we're going to raise everything 3. Ooh, no, I think I'll still be on my thing. So this point will move up to 3, up to 4 because it was at 1. 0 will move up to 3. -1 will move up to 2, up to 3, up to 4. So it's really, like I said, if you can graph those 5 points initially for one cycle, everything else is basically then just moving those points. I can't talk and count at the same time, sorry. All right, this one goes up to 4. All right, so the new sinusoidal is at 3 because that's the point that goes right through the middle, and then we just connect our dots. There we go. Okay, so that would be a vertical translation of 3. And if I wanted to go down 1, then so -1 is the new sinusoidal. Remember, that just means that's the halfway point. So if I was at 1, I'm now going to go down 1. Everyone is just going to drop 1 place, and you would have that. And we could carry that back. This would drop 1, this would drop 1. Everyone drops 1. And so your graph, 2 cycles of your graph, would look like that. Get rid of that little piece. Okay, so that is your vertical translation. Now, just to kind of start to get you ready, putting everything together, here, if I was to graph 1 plus 2 sine x, so that 1 means that my sinusoidal axis is going to be, so that's going to be a vertical translation, up 1. And this 2, since it's in front of the sine, that's a vertical dilation by a factor of 2. All right, so what I usually do is I do my sinusoidal axis first. So my sinusoidal axis is going to be at 1. So I kind of map it out here, and I'm going to label that. So that is at 1, just so we know where we're at. And now my amplitude is going to be 2. So sine always starts on your sinusoidal, wherever that is now, ends on the sinusoidal, halfway point on the sinusoidal. We can do that backwards too. So at the pi's, there we go. So there's my sinusoidals. Now my high is going to be a high of 2. So I'm going to go up 2 from my sinusoidal and down 2 from my sinusoidal. Same thing over here. This one now will be down 2. This one will be up 2. And that would be putting together all your vertical transformations, both the dilation and the translation. And that's how that would look. Okay, so C is going to represent the vertical translation. All right, our last transformation, this one is a little bit harder, especially because we're doing everything in radians. It's actually easier in degrees, but we don't want to keep going back and forth, especially with graphing. We want to stick to one form. So what this one does is a horizontal translation. It's going to shift your graph right and left, and as normal, it'll work, since it's horizontal, works opposite of what you would expect. So the number D, whatever this is, that is going to be what your shift is. It tells you where to start your cycle. So we're going to start at pi over 4, positive pi over 4. It's kind of like setting that what's in the parentheses equal to 0. What would make it equal 0? Positive pi over 4. Now, we know that a normal cycle for cosine is 2 pi. So now when I end, I'm not going to end at 2 pi because I shifted everything forward pi over 4. So to figure out where I'm going to end, I have to add pi over 4, which means I need a common denominator. So I have 8 pi plus pi on top, so I'm going to end at 9 pi over 4. So notice I got rid of the grid because now you are going to be labeling your axes. We're going to start, there's no vertical translation here, so I still start on the x-axis. I'm going to start at pi over 4. I'm going to end at 9 pi over 4. So I'm not actually doing the graph, I'm just labeling it. So this is 9 pi over 4. I want the halfway point, before that represented pi, But the easy way to do this is average what you have here. Remember, when you take an average, you add the two numbers. So 9 pi plus pi is 10. Half of 10 is 5. So this will be 5 pi over 4. And then to get those quarter points, I'm going to average 5 pi plus pi is 6. Half of 6 is 3. So this will be 3 pi over 4. You're just taking an average. 5 plus 9 is 14. Half of 14 is 7. And so these are going to be my markers. Notice that I have an amplitude of 3. So that means I'm going to go up to 3 and down to 3 from the sinusoidal. Now that we have everything labeled, so your sinusoidal axis is still the x-axis, it's still at 0. We're graphing a cosine, so remember, cosine starts high, but now it starts at pi over 4. So we start high, remember it ends high. What I always kind of like to do is, remember when you were in elementary school and you learned how to write your numbers and they gave you that little dotted paper? I like to kind of dot it out so I can keep track of my highs. In the middle, so remember, cosine starts high, ends high. In the middle, it's at its low. And at the quarter points, you hit the zeros. And now we're just going to do one cycle because it starts to get harder. And if you can do one cycle, that's awesome. There we go. That would be your graph showing a horizontal translation. Now let's take a look at if we did 2 sine x. You know what? I'm not going to make it look uglier. So I'm not going to do the parent graph. I do want you to notice it does have an amplitude of 2. But now we are starting at a negative, because this is the same thing as x minus a negative pi over 2. So you're starting negative pi over 2. We're moving everything backwards. So this will be negative pi over 2 is where I'm going to start. Where am I going to finish? Well, that's going to be 2 pi, which is our normal ending point, minus pi over 2. To get a common denominator, we're multiplying top and bottom by 2. So 4 pi minus pi is 3 pi over 2. So I'm going to end here at 3 pi over 2. And again, we take averages to find those 5 markers along here. So 3 pi minus pi is 2. Half of 2 is pi. So this will be pi, same denominator, over 2. What is halfway? Oh, you know what? I should make this look at least equal distance. So we have here, let's move our negative pi over 2 back. Halfway between negative pi over 2 and pi over 2 is 0. So we'll hit this point. And then for our quarter point here, 3 pi plus pi is 4. Half of 4 is 2. 2 pi over 2 is just pi. Also, if you look at your unit circle, what's halfway between pi over 2 and 3 pi over 2? It's pi. All right, we have an amplitude of 2, so I'm going to put up here a 2 and a negative 2. And now let's do our graph. So this is a sine graph. Remember, sine starts on the sinusoidal, and which has not changed. It ends on the sinusoidal, and it hits the sinusoidal axis in the middle. The first quarter point, it goes high, then it goes low, and so then you can draw, you just connect the dots and draw your graph. All right, so I guess I should fill in here, we ended at 3 pi over 2. So it is a little harder with the radian because you have to work with fractions, whereas with degrees, you can kind of just add the degrees, but it's not that bad. We'll keep it friendly. So how does D affect the graph? It shifts or translates the graph right and left, right and left. So you would be going right if you saw x minus d, and you'd go left if you saw x plus d, because it's x minus a negative d. Okay, well, let's try this one here. We have 2 cosine x minus pi over 2. Notice that we're going to start at pi over 2, because that's going to be the d value. 2 pi plus pi over 2 is going to tell me, so here's pi over 2, where I'm going to end. We want to have a common denominator, so I'm going to end at 4 plus 1, 5 pi over 2. Halfway between 5 pi and pi, if I add those I get 6. Half of 6 is 3, so this will be 3 pi over 2. And then the quarter points, 3 plus 1 pi, 3 pi plus pi is 4. Half of 4 is 2, so 2 pi over 2 is just pi. Again, that's what's halfway between those. Here, 8, half of 8 is 4. 4 pi over 2 is actually 2 pi. And which makes sense because we're shifting everything forward pi over 2. So you're going to go pi over 2 beyond the 2 pi. And now we have an amplitude of 2. So I mark my y-axis with a 2 and a negative 2. And if you want, you can do your little dotted lines. That's why you should do this on graph paper. So it's cosine. Cosine starts high, ends high, in the middle goes low, and hits your zeros at the quarter points. And now we just connect the dots. Okay, let's try this last one. You stayed with me this far. So I'm going to start, since it's x plus pi, remember that's x minus a negative pi. So I'm going to start at a negative pi. We're going to shift everything back. And so 2 pi minus pi means I'm going to actually end at pi. So I should probably stretch this out, but you know what? We're gonna manage to fit this in here. I need a little more space. I'm gonna make my negative pi way right back here. So if that distance is negative pi, this distance would be pi. Hopefully you can just reason that the middle point would be 0. And then this will be pi over 2, and this will be negative pi over 2. So we ended at pi. This is a sine graph, so it has an amplitude of 3. So we go up to 3, down to 3, and now we're going to do the graph. So sine, remember, starts on the sinusoidal, ends on the sinusoidal, hits the sinusoidal in the middle. First quarter goes high, the second quarter it goes low, and then we just connect our dots. That wasn't the smoothest graph in the world, but hopefully if you stayed with me this far, that means you get it, okay?